All right, problem 3 asks us to determine the independence of something in here. So let's see. A group of 25 people contains 10 brunettes. That's brown here. Brunettes means brown here. 8 blondes and 7 redheads. Of the 20 girls in the group, 8 are brunettes, 6 are blondes, and 6 are redheads. A person is selected at random. Are the events being a girl? So being a girl is one event, and having brown hair, independent. Those are my 2 events. I want to determine if they're independent. And again, having brown hair, that means we're talking about brunettes. Okay, so in general, 2 events are independent if we can show, so A and B are independent if the probability of that event A occurs given that event B occurs equals the probability that event A occurs anyway. Right? The probability that A occurs given that B occurs, if that's the same as just the probability that A occurs, 2 events are independent. Or you can show the other way. The probability that B occurs given that A occurs is the same as the probability that B occurs on its own, regardless of A. Then those 2 events are independent. It's not really an intuitive thing to determine if 2 events are independent. It really is going through these cases and seeing if either one of these are true. And in this case, instead of A and B, we're going to be talking about being a girl or being a brunette, having brown hair, right? So those are the 2 events we're considering. And we should also recall that the probability of A given B that's conditional, right? Is the probability that both events occur. Probability of A intersect B divided by the probability of the event that we know has already occurred, divided by the probability of B. So, So recall this. All right, this is what we need to remember, and this is what we're trying to show. So let's do it. So there's a lot of moving parts in here. Let's find these individual probabilities first. All right, let's find the probability of being a girl. Probability of choosing, if you choose one random person from this group, what's the probability that person is a girl? So that's equal to the number of girls divided by the number of people, number of outcomes in the sample space. So that's, how many girls are there? They clearly tell us there's 20 girls in the group. And how many people are there total? There's 25. If I want to simplify this, I divide each by 5. So the probability of being a girl is but the probability of selecting a girl out of these 25 people is 4/5. How about the probability of selecting a brunette? That's equal to the number of brunettes divided by the number of people. How many brunettes are there total? 10. There's 10 people with brown hair. Now they could be men, they could be women, right? It doesn't, we're not specifying. And there's 25 people. So out of those 25 people, 10 of them are brunettes. And we get more information down here, but we'll see if we need that. Divide each by 5. So the probability of choosing a brunette is 2/5. Okay, those are important probabilities because that's what we'll need to show that this given that should be this given that should be that, either or. Okay, so we need to show. Let me do this in a different color. Oops. So we need to show that the probability of being a girl, choosing a girl, given that you chose a brunette, is the same as the probability of choosing a girl, period. Or we need to show the probability that choosing a brunette, given that we know you chose a girl, is the same as the probability of choosing a brunette. And in this case, we know the probability of choosing a girl. We need to show that's 4/5. If we show this is 4/5, or we show that this is 2/5, then we're done. Right? Either or. We don't have to show both. Just one. One has to be true. So let's try to show this, right? Let's try to find the probability that we choose a girl, given that we know we've chosen a brunette. Okay, so this is what we need to show independence. If both of these are not true, then the events are not independent. Okay, so let's start with the first one. Use a different color. I don't know, let's use orange or something. So the probability of choosing a girl, given that you chose someone who was a brunette. So remember our conditional probability formula, we know that's the probability that you chose a girl who is a brunette divided by the probability that you chose a brunette. Now, we didn't find this probability, right? The probability that you chose a girl who was a brunette, a girl and a brunette at the same time, right? The intersection of those two events means you chose a girl who's a brunette. Let's find that. So, and then if we're thinking about the probability in the same way, the probability of a girl and a brunette is equal to the number of girls who are brunettes divided by the number of people total. So how many people in this group are both girls and brunettes? That's what this is asking me, right? How many people are both girls and brunettes? So here it says of the 20 girls, 8 are brunettes. So that means, so there's 10 brunettes in total. 2 of them are men, 2 of them are men, and 8 of them are women, right? Yeah? If there's 10 brunettes total, and 8 of them are brunettes who are also women, the other 2 are brunettes who are also men. I hope that makes sense. So the probability that you chose a brunette, a girl who's a brunette, is there's 8 of those out of the 25 people. 8 girls who are brunettes out of the 25 people. That's that probability. And we found the probability that you chose a brunette is up here, 2/5. Or I'll use 10 out of 25. It'll be easy to calculate here. 10 out of 25. Okay, these denominators are the same here, so I can that. So I'm left with 8 over 10, which if I simplify, divide both by 2, is 4/5. And that's what we're looking for. The probability of choosing a girl, given that you chose a brunette, it does equal the probability that you chose a girl, which is 4/5, which is what we need. So I can literally stop there and say, yes, these two events are independent. But I'll continue. I'll show the second one too, because, I mean, let's see, in case you used that instead. So let's check the probability of choosing a brunette, given that you chose a girl. So that's the probability that you choose a brunette, who is also a girl, divided by the probability that you chose a girl. All right, so choosing a brunette and a girl, that's the same as choosing a girl who's also a brunette, right? Same, 8 out of 25. And the probability of choosing a girl we found before was 4/5, or 20 out of 25. Same thing, I'll cancel those denominators there. So I've got 8 out of 20. Divide each of those by 4, I guess, right? 4, right? That becomes 2 out of 5, which is exactly what we have here. So because the probability of these conditional probabilities equal these simple event probabilities, yes, these events are independent. Again, you only need to show one of these. You don't need to do both. But I just wanted to show you that they both worked.